All right, welcome back to the main session, everyone. We will continue with the following exercises. We have just completed some regarding the sheet metal exercises. We have just completed some of the parametry components and drawing generation, I mean. So following this, we will have to continue with the sheet metal features. So there are several ways to create sheet metal features in BricsCAD Mechanical. There are ways to do it from scratch, two different ways that I will be displaying in the following exercises. I will be doing both this exercise and the next exercise right after each other. And then we will be going into a breakout room like previously. This is because the exercises are fairly straightforward and simple, and they tackle a very similar topic, just two different approaches to it in a sense. So to start with, I will open up BricsCAD, of course, and open up a new drawing. And we will use this drawing to model our sheet metal part from scratch. The first one will be working with creating a base flange and adding on flanges to this. So I will go ahead and start by drawing a rectangle from 0.0.0 point in my drawing with a width and length of 100 by 255 millimeters. Now this is going to be our base flange, the base design of it. And we can now go to the sheet metal tab on our ribbon. And here we can use the base flange command. Then it will ask us to select a region or a polyline, a closed polyline. And as we have that here, I can select it, hit enter on my keyboard. And here we can see a representation, a preview of what the flange will look like. You can see that the control toggle settings is something that we can access here. What this does is that it will allow us to choose if the base flange should be positioned on top of our sketch, in the middle of the sketch, or on the bottom side of the sketch. I will just accept the base or the default option, which is on the upper side of our sketch, and accept it. Now you can see that the sheet metal part changed color. It has two different types of bluish hues. This indicates that it is a sheet metal flange. And we can go to the mechanical browser as well and see that we have now a flange located here. If I select the root node in my mechanical browser, you can also see, if I scroll all the way down, that we have some sheet metal settings as well, such as the thickness of the sheet metal, bend radius, bend relief width, meter gaps, and so on. This will become more apparent what they actually do at a later stage as well, as we keep adding to our design. All of these settings are set by default in this template. If you want to change the initial parameters or the initial settings for this, you can go to the settings window. And through here, we have a option called, or a category called sheet metal. And we have the category initial parameters for modeling and unfolding. So here you can change the default thickness of the model, the default bend radius, and so on, as well as unfolding options such as the K factor, which will be familiar to you if you have worked with sheet metal before. We also have a category for feature colors. So you could see that the sheet metal base flange has this bluish color to it. If you want to have different colors representing the different features, you can change that here. And you can toggle them off altogether if you wish. Meaning that the part will just have the basic material colors that you have assigned to it previously. But for this exercise, I will use the default settings. So of course, this is just a simple solid or a simple flange, just completely flat. We want to add something more to it, so we can add some more flanges. To do this, we have the toolset at the top of our screen on the ribbon under the sheet metal tab to use. And here is the edge flange command, which will allow you to create more flanges. There are some different options. Typically, you can use the edge flange, the normal configuration. When you use this, I will select it and select the bottom edge of my flange. This is because I want the flange to curve downwards. If I select the top edge, it will curve upwards. And you will see that with the default option, it will always stay within the size of the base flange that we created. So the size of the sketch will be retained. The front face of the new flange will still stay within those dimensions. Meanwhile, if I use the edge flange outside option, then it will push or pull the flange outside of the sketch and take the thickness of the sheet metal outside of the sketch, essentially adding those 2 millimeters of thickness to the outside of our initial base flange. But the original base flange will keep it within the original positioning. So I will draw this downwards, following along with the guide, 90 degrees downwards with a length of 13 millimeters, like so. Just as when you are extruding something or drawing a line, you have the dynamic dimensions that you can fill in. And you can see a new flange has been created, and automatically a new bend has been created for us as well. Now this bend radius depends then, of course, on the bend radius that is defined in our settings that you can change at a later stage if you want, or change before you even create this if you want. Now, I also want to add a flange to the backside. So once again, I will activate the edge flange tool. But in this case, I also want to add an offset from the edges of each side. So we have a setting called, or a command option that is called width in the command line dialog. So if I select width, it will then give me the option to choose how far in I should want to offset this edge. In this example, I will type in 32 millimeters. Then it will ask me for the other side as well. And once again, 32 millimeters. And then it will take me back to selecting the height and the angle of my flange with those offsets that I have assigned now. So I will give this a value of 62 millimeters, 90 degrees upwards. Hit enter to accept. And once again, it creates the flange for me with the bend for it. You will also see that there is this green color here and this little cutout. This is what is called a bend relief. What this does is that because when you are in a realistic setting and you actually want to manufacture these parts, if this area was completely filled with material, then you would not be able to very easily bend it, and it would essentially not be possible to bend it precisely or accurately. Therefore, there is a small cutaway that allows it to be bent more easily. These are once again settings that you can access in the bottom left here in the mechanical browser. The bend relief settings, the width of it you can change here, and so on. I will also go ahead and add a base flange on the top here that I want to go backwards. So I will select the edge on the back. Hit enter to accept the selection, and then I can draw it backwards. Like usual, if you just hover your cursor around, you can see that the flange will move in different angles. But if you hold down the shift key, it will lock to the different axes, making it easier to make perpendicular planes or flanges. This will be 13 millimeters as well. And also now I have a bend here. So moving on, we can see if you want to, for example, change the angle of certain things at a later stage, you can hover over them and you can use some of the tool sets that you can see in the command or quad here. You have a new category when you're working with sheet metal that has very specific tools for the sheet metal purpose. And here you can select, for example, the rotate flange option, and you can then again choose a new angle for it very easily. If you want to move a certain face also, you can hover over this face in the back here, for example, and we can call the push-pull command, let's say, and I want to pull this face forward. You can see it will still retain the information of the thickness of the sheet metal. It will not add thickness to it. It will simply just move that flange, making it very easy to modify your designs in that sense. In the exercise, there's also an example where you can dissolve certain features of sheet metal. When it is in the state of being a sheet metal part, it will keep these parameters such as the thickness and bend reliefs and so on. But if you want to make any changes, you can use the any custom changes outside of those parameters. You can use the SM dissolve command. For example, on this face, I have done so now. And then if I try to push pull it, it will not retain the sheet metal information anymore. And I can add material to this. But for this exercise, we wanted to stay as a sheet metal part. So I will undo that dissolve feature and continue my design. I also want to add some flanges on the sides here that go downwards. So I can select this edge and I can select this edge. You can do it one at a time, but you can also do them both at the same time. Like so, you can see it will make them symmetrical for me. I will take them downwards with a distance of 66 millimeters and 90 degrees. And you can see on the corners here, it has also created these bend reliefs for me, allowing it to be able to be produced in a realistic sense as well. You can see these red features as well. These are called junctions. And they are basically just corners that are cut and that should line up. So they are still attached to each other. However, they will they allow it to be split when it will be unfolded in the future. I will also make some more flanges symmetrically, just using the same approach, selecting two edges at once, using the edge flange tool, taking these outwards 25 millimeters. Once again, doing the same thing on these bottom sides, using the edge flange tool, pulling them outwards 15 millimeters. And you will see once again, it creates these bend reliefs for me, bends and everything. So you have a lot of manual input on how you want the design to work, but there's also a lot of features that help you along the way as well. Now, even though this is a sheet metal feature, we can still add extrusions and cutouts, such as holes, for example. In this exercise, we will add a slot to cut out on each side here of the part. To do this, we can use the library panel, go to the folder for holes, and then select the slot. And you will remember from the parametric components exercise that we had the holes that had the unite layer and the subtract layer. These holes work with the subtract layer and will allow you to place these to remove material from what you place it on. These are also fully parametric, so you can change the parameters after placement or before placement. I will change the diameter to 5 millimeters, change the length to 40 millimeters, and the depth doesn't really matter, but you can change it to the thickness of the sheet metal if you wish, like so, and then we can place it. If it is angled like this, you can use the rotate option in the command dialog and rotate it 90 degrees. Then you can place it on the face here. Then, of course, we want it on the other side as well. So we can select it, use the mirror command, and define a mirror line. Basically just drawing a straight line through the middle of the part to define the line that we should be mirroring along. Like so. Then we can turn off the BC subtract layer to have a more clean view of our drawing or model. And now we are almost complete with our design here, so we can select some of the different edges and still add some chamfer features, for example. I will select these smaller edges, this edge, this edge, this edge, and this edge. And in the quad, I can select the chamfer tool like so and give it a value of 5 millimeters. Just to round out that design a bit more. I can also add a chamfer on these parts, but I can make it a bit larger and make it 50 millimeters. Now with this exercise comes also a block that we can insert. So I will use the insert command, select the browse option, and I will locate the folder for this exercise. I will find it under sheet metal from scratch and starter files. Here is the holes 2D block. This is what we are going to insert onto the top of our model, and we want to use it to extrude holes through it. So I will enable the explode feature here, meaning that it will normally be inserted as a block, but by exploding it upon insertion, it will be directly converted into a 2D geometry. So I will just hover it over this face, lock it onto the face with my shift key, and I can select, for example, the corner down here to insert it. And like this, we have the sketch. We can use a selection window to select the sketch. And we can use the extrude tool. Just dragging the cursor down and extruding this sketch. And like that, we have a finished sheet metal part. We can now use the unfold tool on the top of the screen. On the sheet metal tab, you can see we have some different options. We will just use the normal unfold body option for now. By activating it, it will ask us to select a flange. I will just select the top flange here, and it will generate an unfolded view of our model. Then we can place it once more to just clicking my placing and accepting the view. And here you can see we have a view with the unfolded plates. We also have the largest measurements of the plates, letting us know exactly how much raw material is needed for this. It will show you the bend lines and the radius and angle for each of the bends as well. So that is one of the ways of creating a sheet metal part. We will move right ahead onto the next approach to making sheet metal parts. Since I already explained some of the concepts when making sheet metal parts and some of the sheet metal features, I will not spend as much time explaining it on this example. Once again, we can start by making a rectangle. I will make this 100 by 200, and I will extrude it upwards by 100 millimeters. And I will add a chamfer to this edge of 50 millimeters. Then I will just extrude the front face of this. Extrude it by 50 millimeters. And I can also rotate the front face here, for example, around this edge and rotate it downwards 15 millimeters. So just with some basic 3D modeling, direct modeling, I have created the shape. And so we have a just solid 3D model. And this is what we will use to create a sheet metal solid. So instead of using a base flange and adding onto it, we can use a pre-existing solid like this and just convert it into sheet metal. So first off, under the solid tab, I will select the shell command. I will select the solid I want to shell out, and then it will give me the option of choosing what faces I want to remove. I want to remove the bottom face, so I will select that, and you will see it lost its highlighting. I will hit enter to accept, and then it will ask me for the shell offset distance. This will be the wall thickness of our solid. So basically, we are cutting away all the internal solids and making it a thin-walled solid. So I will enter the value of 2 millimeters, hit enter, and you will see we now have a thin-walled solid, the walls are being 2 millimeters thick. Then I want to add a window on the front first before doing anything else. So I will use the offset tool like we have done previously, offset it inwards by 10 millimeters. Use this sketch to extrude a hole. Not through the entire solid, just enough to puncture through the wall thickness. And then I think we are ready to convert this into sheet metal. If we go to the sheet metal tool or sheet metal tab on the ribbon, we have the convert to sheet metal option. By selecting this, it will ask us to select a 3D solid. I can select the solid, of course, hit enter, and you can see it is converted into the colors of the sheet metal like previously. Now, one thing to keep in mind is that, of course, it does not have all the bends. It does not have the bend reliefs. It does not have the different junctions. So it is not able to be unfolded at this stage. So with this approach, we have to more manually, with some automation, of course, place some of these features to be able to unfold our design. But it is a fairly simple process. First off, we can use the relief tool in the sheet metal toolset and apply it to the entire model. And automatically it will add these reliefs onto all the different corners of our model. Then we can go ahead and define some junctions where we want to split the model when it gets unfolded. So I will select the junction tool. Actually, we can already select some edges. For example, we can select the edges here, all the way down on the side, except for the back one. Do it on this other side as well. These edges are where we want to place junctions. So with these selected, I will activate the junction tool, and it will create these junctions. You can see some of the reliefs were removed as they are not necessary anymore. However, sometimes it is good to have them just in case they will be used at a later stage, and it automatically applies them. So there is not much of a reason not to include them, in my opinion, at least. Then we can start applying some bends. We want to bend it, of course, on these edges. So I will select the edges on the front here and the one on the back, as well as these edges here. And I will activate the bend command or bend tool in the sheet metal toolset. And like so, we now have completed this design. It should be able to be unfolded, so we can use the unfold tool again, select a face, and like so, we have a unfolded representation of this. Now we have a big open empty area in this unfolded view. That might not be ideal in terms of saving space when trying to actually produce this. It will be a lot of wasted space, especially if you make a lot of these components. So let's say hypothetically that we want to preserve as much space as possible in our design. Then we can try to unfold it in a different way to eliminate this big open space in the middle of our part. So we will just change some of these designs. You will see that in the guide, there is some steps. There are some steps that will tell you to, this step 17, using SM imprint is something that is needed to do the following steps in older versions of BricsCAD. In newer versions of BricsCAD, it might not be necessary, but we can use it anyway, for example, just in case. Some of these steps are automated in newer versions. So we will select or actually, I will just try and convert this junction into a bend. You can see we have these solids or these junction features, these red lines. When you hover over them, they will be detected as junctions. So you can have the option here to convert it to a bend. So if you just hover over it and you select that feature, it will automatically replace this junction as a bend. So it is very simple to convert and switch between these features as needed. Of course, the part is still now not able to be unfolded anymore, as we now previously split it down this line. And now we have a bend, so we have to split it somewhere else. In this example, we can try to split it in the corners here to isolate the bends on the sides from the rest of the part. To do this, we have a tool called SM Split. On the top of my screen on the ribbon under the sheet metal tab, we have the Smart Split feature, the Normal Split feature, and Smart Split Propagate, which is what we will focus on now. You can manually place one, or you can use the Smart Split, but I will use Smart Split Propagate. What it will want us to do is to select a corner. So I will select this corner here. And just by selecting this, it automatically detects that it should be split diagonally here, and that it will also apply it to the 4 other corners for us. So it is a very easy and automated process that allows you to easily split it without having to do them several times at once. So now you can see that we have this feature being split in each corner. And our model should be able to be unfolded now. You can see in the mechanical browser that we now have a red unfolded view because the previous unfolded view is no longer the current representation of this. And we also have 2 different bodies, as you can see. Since we split the bottom side here from the rest, we now have 2 bodies, so we have to unfold both of them. First, I will select the main part. Then I will select the last part. And place them like so. So as you can see, we changed up the unfolding process. You can see we added the flanges on the left sides, left and right side, and we split this bottom part away from the rest of the sheet metal part or flanges, and we saved quite a bit of space by doing this way. So that concludes the two different ways that you can create sheet metal parts in BricsCAD from scratch. Now it will be time for you to try it yourselves, and we can move on to the breakout rooms.
Download BricsCAD today and start your free 30-day trial.